This video is going to be on hyperproteinemia. The first subcategory of hyperproteinemia is selective hyperalbuminemia, and this means that the albumin concentration is increased, but the globulins are not. And usually when this happens, the globulins are high normal, so it probably is increased for the patient, it just hasn't increased out of the reference range. So the only cause for increased albumin that you're going to learn in this class is dehydration. And with dehydration, it's not that the albumin is absolutely increased, it's a relative increase. And it's increased because there's decreased concentration of water. Panhyperproteinemia is when there's an increase in albumin and globulins proportionately, and it's the exact same reason as selective hyperalbuminemia. It's dehydration. So again, it's a deficiency of water and not that there's an increased production of protein. Selective hyperglobulinemia is when there is an increased globulins that's disproportionate to the albumin concentration. And this is the hyperproteinemia that I'm going to focus on for the rest of the lecture. The two main causes of selective hyperglobulinemia are antigenic stimulation or inflammation and neoplasia, and particularly lymphomas, B-cell lymphomas, or plasma cell neoplasms. So to better explain hyperglobulinemia, I'm first going to go over serum protein electrophoresis. So during serum protein electrophoresis, the serum is applied within a gel. So let's say this is the start point where the serum is inserted into the gel. And then there's a charge put in the gel where the proteins start to migrate towards the positive end or the cathode. And the proteins migrate depending on their size and their charge. So small, negatively charged molecules migrate the furthest, and that is albumin characteristically. And then large molecules and positively charged molecules migrate the shortest distance. So we can see that albumin, which is this tall peak, there's lots of albumin. About half of the protein in the sample is albumin. So the y-axis is the amount, with the higher amounts represent a higher concentration. And then we can see that there's approximately half of the remaining proteins is the globulins. So the globulins are essentially any protein except albumin. So the main purpose of a serum protein electrophoresis is to differentiate a polyclonal gammopathy from a monoclonal gammopathy. So I have two normal electrophoretograms, and I'll superimpose both of those types of gammopathies. So with polyclonal gammopathies, this is due to antigenic stimulation or inflammation. And during times of inflammation, there's lots of different clones of lymphocytes producing lots of different clones of immunoglobulins. So there's increased concentrations of different immunoglobulins of different sizes and different charges. So what happens is that you get a peak within the globulins region that has a wide base. And the width of the globulins peak is often wider than the width of the albumin peak. That's kind of our internal micrometer, if you will. And the way we do that is I go halfway up the globulins peak, and I look at the distance halfway up the globulins peak, and then I go halfway up the albumin and look at the width of the albumin peak and kind of compare those two widths. So this one's longer, so the interpretation would be polyclonal gammopathy, i.e. inflammation. With a monoclonal gammopathy, there's lots of different, lots of the same clone of lymphocyte producing the same immunoglobulin. So this occurs with lymphoid neoplasia. So either lymphoma or a plasma cell tumor such as multiple myeloma. So there's lots of these same clonal population of lymphoid cells producing the same immunoglobulin that has the same size and the same charge. So the peak within the globulins region is narrow. And again, you're going to compare the width of the globulins peak to the width of the albumin peak, and if they're about the same size or the globulins peak is narrower, then the interpretation is monoclonal gammopathy, i.e. lymphoid neoplasia.